It's 2 o'clock Eastern time, so why don't I kick things off? Um, Good afternoon, everyone. Welcome to this afternoon session entitled Adapting Lean for Sustainability in the Value Chain. Our speaker today will be Russ Snyder. Um, Before I turn things over to Russ, let me go through a few logistics. My name is Mike Gilman, by the way. I'm the moderator for this afternoon session. I represent ASQ's Energy and Environmental Division, who has been one of the 5 divisions coordinating this conference, ASQ Synergy for Success, which has been a success based on the attendance and all. So we're doing good. I'll remind you, as you've probably heard before, that questions should be submitted using the Q&A feature on the bottom of your screen. I'll be screening those questions and collecting them and delivering the questions to Russ at the conclusion of his presentation. You can also offer some comments for the crowd in the webinar chat that you also see on the bottom of the screen, and we'll be looking at those little comments in the chat as well. So why don't I now give you a little background on our speaker, Russ. Russ is retired as a senior director at Intel Corporation, small little company, managing their supply chain operations, and he retired in 2023. Russ is currently the principal of Six Sigma Supply Chain, a consultancy for applying lean into the supply chain process. Russ is a registered professional engineer, has an MBA, and is a Lean Six Sigma Green Belt. Russ is a frequent speaker at conferences on topics ranging from risk-taking to supply chain resilience. Russ won the 2020 Supply Chain Lean Excellence Award from the USC Marshall School of Business. Very nice. He's most recently been featured in the ASQE Executive Roundtable discussions on sustainability. Very nice background, Russ. At this point in time, I'll turn the session over to you, and we'll keep in touch, and I'll keep you posted on comments that I'm receiving. Go ahead, Russ.
Hey, thanks, Michael. As Michael said, my topic is adapting lean for sustainability in the value chain. And I changed the name from supply chain to value chain, and I'll get into that a little bit later. But what I think it means is that we can look up and down the value chain, not just say in our factories or in our workplace, but in our supply chains, in our design teams, how we design products, how we influence our customers to become more sustainable. And I hope to open up your horizons a little more on what type of projects actually fit under the lean umbrella. So as I say that, let's go ahead and get started. Oh, my slides aren't advancing. There they go. First of all, we'll do some definitions and get that out of the way. One of the primary focuses on sustainability are greenhouse gas emissions, and those are called Scope 3 emissions. And the definition from EPA is the result of activities from assets not owned or controlled by the reporting organization, but that the organization in itself affects its value chain. And the organization's value chain consists of all upstream and downstream activities, which is highlighted in ISO 14001 life cycle model. The triple bottom line is a framework that focuses on sustainability by considering its impact on people, planet, and profits. And the circular economy is an economic system based on reuse, regeneration of materials and products, especially as a means of continuing production in a sustainable or environmentally friendly way. And the notion of this circular economy encourages us to minimize waste, which I think is the primary goal of lean. So a couple of other definitions. What I'll talk about in the results of some of these examples or case studies that I want to show is where we converge, where lean, agile, resilient, and sustainable practices complement each other and become synergistic. And you'll notice I'm really excited about the title of the conference as Synergy for Success. And I think what you'll find throughout the presentation is there's so much synergy between lean and sustainability. Um, and I hope that's your key takeaway. And then divergence is where lean, agile, resilient, and sustainable practices create trade-offs that have to be managed. And often these trade-offs are across internal organizational boundaries or customer supplier boundaries. And I think you'll see a lot of case studies that I'm going to go through that actually work across the boundaries. And then also, of course, I have my references at the bottom when you pull down the slides. Our ASQE organization in 2024 published in their Insights on Excellence the importance of the carbon footprint in our supply chains. Up to 90% of an organization's actual greenhouse gas emissions are, unfortunately, from our supply chain, which makes it a little harder to measure. It makes it a little harder to get the information. What I'll show you is how that information comes through suppliers' annual environmental reports, and primarily because the EU is requiring pretty detailed reporting about environmental emissions. So let's just briefly go and revisit the ISO 14001 lifecycle model. I call it the influence model because where I feel, and through my experience, and where most organizations apply lean is they apply it in the production zone. And that's in the factory. It could also be in the office. But a lot of times we don't go apply lean to our design practices. And a lot of times we don't try to go apply lean in our supply chains for all the materials that we're acquiring to build our product. Similarly, upstream, do we ever go try to influence our customer to become more sustainable? Or it may be vice versa, that our customer is encouraging us to become more sustainable as they require us to report emissions and our scope 3 emissions. So, and then the last one is, how do you manage the end of life of a product? And I'll share a couple things with how we repurpose products and some of the methodologies behind what we do there. So I hope that as we look up and down the value chain, that we're going to come up with perhaps some alternate ways of looking at sustainability. First of all, I'd like us to start thinking differently about our position in the value chain. Just a little bit of background. In our organization, we managed manufacturing for Wi-Fi modules, and I did that for about 15 years. And what I noticed was, and some of the things I had to change in our organization is that our organization expected everything in our factory to be perfect, everything in our design to be perfect. And oftentimes what that meant was, if we wanted to have the highest yields, then sometimes the way we designed our product forced our suppliers to have less than optimal yields. And in many cases, our engineers were giving pass downs to our suppliers instead of collaborating with our suppliers. And then I'll go a couple steps further. We provided, in some cases, unnecessary specifications for suppliers that drove over-processing, defects, and higher greenhouse gas emissions. Sometimes specifications were defined without supplier input and were quite wasteful. When we look at yield management in our factory, oftentimes we can squeeze the supplier and cause over-rejection at our suppliers. And then lastly, collaborating across lifecycle boundaries can unlock large sustainability and lean cost opportunities. So I think before I leave this slide, I really want us to think differently about how all of our folks approach the external sources of things in our value chain, and that includes our customer as well. Now, Beth Cudney wrote a book about lean sustainability, and this framework is directly out of her book. And, I asked her permission to use it, and I think there's a few key things I want to focus on. In the very center, it shows a model. The Plan, Do, Check, Act is the core. That's our lean process. And surrounding the lean process are the 5 R's of sustainability: refuse, reflect, reduce, reuse, and recycle. Um, and what I'll show as we go forward, how these 5 R's either diverge or converge with some of the lean projects that we're going to talk about. And I've already covered ISO 14001, which Beth lists as her highest sustainability tool on her chart on the upper left hand of the slide. But what I want to add is, and talk about, is great synergy between lean and sustainability. So as I add on to Beth's model, I think that I tried to come up with some new wastes that we would identify as additional lean wastes. But when I really came down to it, I really couldn't add any lean wastes because they're already defined. Now, what's not defined is how we measure the waste. And typically in our lean projects that we did, we either measured time reduction or dollar reduction was our measure of success. And if you look at the outer circle of arrows, I add in things that are related to sustainability. Number one is energy, and electricity, as you'll see in some of my case studies, is one of the most one of the largest generators of greenhouse gases. And then, of course, emissions from the factory or from energy, effluents, which I also include water or wastewater or discharge, and materials. So I think that if we actually just measure our projects differently with a couple of different metrics, we can measure dollars, time, and also sustainability at the same time. And what you'll see is there is directly a synergy between dollars and sustainability. But we don't report it out. And what I think we can do by reporting out different ways of measuring our projects is we're going to gain traction with senior management about the extra impact that our lean projects are having. So let's expand the universe of project ideas, combining lean plus the 5 R's plus expanded metrics. I think we can start looking at utilities outside of our factories and our suppliers' factories. Facilities, things like HVAC, like boilers, like gases or other things that provide raw ingredients that are from a liquid or heat or otherwise to our factories or our office buildings. Product design. What I'll show you is some case studies that show poor product design, not including the suppliers, and good product design once we included the suppliers, and how much difference it is impactful in both cost and sustainability. And then supply chain. I think we oftentimes put a wall around ourselves and our own factory for our lean projects, but I think you can go deeper into the supply chain. And of course, the customer. All right, I've got one sustainability report from one printed circuit board supplier, and they're a pure plate printed circuit board supplier. So the data you see here is only data on how to make PCBs, one single type of product. And why that's important is if you have a supplier who reports their sustainability data and they make multiple different types of things, multiple different products, then you're not going to know what the emissions factors are for a very specific product. And what's allowed is a method of of measuring greenhouse gases from your supply chain using a hybrid model, meaning if you have a pure play supplier that can provide you an emissions factor, then you can also use it across the board on other suppliers who may be conglomerates if they're providing only a printed circuit board, for example. But I think what I'll show you here is this is one page out of a corporate sustainability report that lists energy consumption, it lists greenhouse gas emissions, air pollutants, wastewater, and waste. Includes water resources used and materials used. It's all on one page, and this is the key data that we'll use to go calculate how much greenhouse gas savings we're going to use from changing how we partner with our PCB suppliers. I want to break down a little more. Energy is the primary source of greenhouse gas emissions for most of us and most of our supply base. And you look at the energy used, how that translates directly to greenhouse gas, both direct emissions from the factory and then indirect emissions from our external energy sources, as well as air pollutants. Now, I know that our current administration is rolling back a lot of the net zero requirements, and many of our corporations are also decommitting on their net zero requirements. First of all, I'm going to say that I think net zero is nearly unattainable unless our energy grid changes to a sustainable, fully sustainable energy grid. And if you look at this particular chart that I also pulled from the same supplier's corporate sustainability report, you'll notice that most of the reductions come after 2030. Sorry about that. And very little reduction comes before then. And I think that by pushing out most of these net zero commitments or decommitting from them, I think it shows you how difficult it's really going to be in the world that we live in today. So what I'm encouraging with our lean practice is that we take incremental steps to make our organizations more sustainable and evangelize to a certain extent when we do a project on what the benefits are from greenhouse gas reduction, for example. So where do I get the data from my supply chain to do some calculations on how much greenhouse gases I may be saving? So I'm going to put the key factors here. You need the revenue from the supplier. You need tons of CO2 equivalent per dollar, which is called an emissions factor. If they don't give you this specifically, you can usually calculate it from the report. Kilowatt hours per dollar. Let's see what our energy savings is going to be. And then from what is the PCB panel revenue? This is the unit of manufacture at the PCB supplier that I'm going to be paying him. Now, $100 it's not exactly our cost per panel, but it's a round number that helps us do good calculations, but it's close. An annual volume, and we're going to use 10 million per year per form factor is what we're going to use, which is also not what we really do, but it makes for easy math. All right, let's go ahead and get into some case studies. And the case studies are all from my background and my industry, meaning it's suppliers that we use to make printed circuit boards for Wi-Fi cards over the years, and other examples for test, etc., for measuring quality of our product are also all from the electronics industry. And I'm not trying to tell you you have to be like us, but I'm going to use them to show an example of how you can interface with suppliers, with your design teams, and with your customers. So we have two products that we sold, two different sizes. One is a 22 by 30 millimeter. That's the one on the right. The main benefit is it allows PC makers to decide at the time of system assembly what Wi-Fi card goes into the system, known as build to order. The 1216 is a smaller card. You see it on the left. It's substantially smaller. Substantially less materials go into this card. It's soldered down and must be soldered to the motherboard at the time of assembly. The main benefit is size and height for low-profile laptops. The problem with it is it carries more inventory risk because you solder it to the board, you can't change it later. Now, let's talk about influencing our designs. And you may wonder, how can we make a lean project to change how our designers go about designing things? But anytime we're designing something with a supplier who has a particular unit of manufacture, we need to be concerned about how we utilize that particular unit of manufacture. And PCBs are fairly standard across the industry in manufacturing in 18 by 24-inch panels. Now, what our particular card is measured in millimeters, really small compared to the overall size of a printed circuit board panel. So you see, we have a decision to make on how we partition that panel into our own product, into a smaller panel, which we can manufacture on our production line. So I'll show two examples. One is we used to design without thinking of our PCB supplier panel size. And we came up with panels that were optimized for our factory process, not his. And the first two examples are sizes of panels that are not optimized, and both of them weigh 16.7% of my supplier's panel, a unit of manufacture, when he makes these sub panels inside it. Design, when we considered the PCB supplier, we could certainly change our design and make it work in our factories. And we came up with 0% panel waste for our PCB supplier. Well, of course, that's going to translate into cost, and it's certainly going to translate into less wasted materials. Now, let's talk about impact of yield management. Now, we can try, as I talked about earlier, we can try to optimize our yields in our factories for 99.9%, whatever the number is in your industry that is optimal. And oftentimes we forget to consider how we may be impacting our PCB suppliers. Well, as our base PCB shrank down to what we saw there, 2230 by 30 millimeters and 12 by 16 millimeters, we used to be able to measure these panels in 6 by 8 inches. They used to be a lot bigger. Well, we had a rule that our suppliers couldn't have any defective locations on the panel when they shipped it to us, so they had to be all perfect. Well, when we got really small units and many more units per panel, our specification caused a lot of yield loss at our suppliers because there are defects in their process. And if you look at the 2230, the larger one, it had a yield loss of about 11.1% of complete panels that the supplier couldn't ship to us. And at the 1216, the much smaller one that had, a lot more units per panel, it was a 25% hit at the PCB supplier. So you can see that our particular yield requirement in our factory drove significant waste and not only material loss, but that translates to greenhouse gas emissions as well. Now, what did we have to do to collaborate with our PCB suppliers on their yield plus our yield? Well, the one thing that we did is we added basically a lookup table on the printed circuit board panel that told which location on the panel was defective. So we would have the PCB supplier fill in. So I filled in one black dot on this lookup table that tells which unit is defective. Well, that means we don't populate components on that location. And that way, the PCB supplier can send us panels with defective units, and we can automatically not process them through our factory. And what this does is I'll look at the divergence. In our factory, we may take a 1% productivity loss. I'm not going to say yield loss because we're not going to use that panel. But the convergence is our PCB supplier uses refuse of material waste of 11 to 25%, significantly higher yield and productivity gains, and reduces energy and CO2e emissions significantly. Now, let's look at some calculations. And I don't want you to get lost on the chart, but it'll show you some of the magnitude of the savings that we can achieve. And the units, our material is measured as panels per year. Greenhouse gas is tons of CO2 equivalent, and then energy is kilowatt hours, of course. And so what you'll see at the bottom is how each thing contributes uh, to the yield of the panel. And if baseline, we're going to build 50,000 panels for the year, the yield loss we showed for the 2230, which is the larger unit, is just because we designed a bad panel, makes our units down to 41,667. If we optimize with lack of optimization, that brings our total materials that we can consume as 34,722. Our savings by optimizing everything is 15,278 panels, 30.5% savings. If you look across the board, I also calculated greenhouse gases using the emissions factor, energy using the energy factor, and then cost as well. And you look across the board, we're at a 30% saving just by collaborating with our supplier and aligning our specification and our factory needs to his specifications and his factory needs. 1216, very similar, except we had much higher yield loss. And you see that our savings on the 1216, the much smaller unit, is 52%. Similarly, using the same emissions factors and energy factors, we calculate the cost savings and energy savings and greenhouse gas savings. Now, I think that some of these numbers are staggering. And if you do a project with your design team that starts collaborating with suppliers and you start racking up some of these savings, it really is pretty incredible to roll these up to senior management to say, hey, there's a lot of synergy across cost, energy, and emissions. Now let's flip the script and talk about the customer in the value chain, which ISO 1 says we need to be concerned with all phases of life cycle of the product. So what could we do if we wanted to influence sustainability with our customers? And what I did was I did a volume mix change. If I assumed 70% volume of the 2230, it shows how many kilowatt hours we use, how much CO2 we emit, et cetera, and how much material we use. If we flip the script and try to encourage our suppliers to take the smaller card, we would use significantly lower kilowatt hours, significantly less greenhouse gas emissions, and significantly less material. And then the savings you see there is pretty substantial. And it results in about a 40% savings. So where do we diverge? We diverge on reuse. Lower supply chain flexibility and greater inventory risk because of the smaller card. I think the trade-off's worth it because the convergence or the synergy with the project is 40% lower energy, CO2 equivalent, and materials. This one is an example of greenhouse gas opportunities in process. Now, many industries' processes are pretty set and they don't change. In electronics, advances get made in solder process. And the most recent advancement in soldering is to use a low temp solder. Now, traditionally, we used to have leaded solder. We moved to lead-free solder. And I'll show that in this chart. The very left column is leaded solder. And you see that CO2 equivalents are about 800 kilograms per functional unit. We moved to a higher temp solder, which was without lead, and you see that it actually added CO2 emissions. It went up by about 10%. By the way, this is a report from the EPA on encouraging us to move to what you see as the third bar that I have circled is now the low temp solder that's available for a low temp solder process. And you see that there's a significant reduction in emissions um, because of the lower temperature. And if you look at the little green box at the bottom, it costs a lot less to mine and manufacture this particular solder than it does the previous lead-free solder. Also an additional impact to CO2. So this is a little history here. In 2002, the EU issued the requirement to move from a lead-based solder to a lead-free solder. Now, some countries in the world still use leaded solder, and in some applications, such as satellites, still use leaded solder because of some tin whiskering and other things that may cause shorts, which they don't want. But for the most part, consumer goods sold in the EU and the US are all lead-free. Where's the convergence here? We refuse to use the lead in any form or including the off-gassing during manufacture. We diverge with an increased CO2 emissions at about 10% and requires more energy to heat the solder. By 2010, low temp solder became commercially available, but adoption has been slow, used only in about 44% of products. And you think, okay, the convergence here, the synergy, is reduces CO2 by 23% and reduces energy consumption from mining and lower melting point of 150 to 170 degrees C. And there's really no divergence. There's really not a downside here. And but it hasn't been adopted now for 15 years. And why is that? No one has mandated it as a government or policy. There's no regulation citing going to low temp solder as a way to get to lower greenhouse gas emissions. But as far as projects, we could certainly do a project to pilot on some products to start encouraging the conversion to a more sustainable solder process. All right. Let's look at manufacturing tests. Now, every product has some kind of test or quality measurement. In particular, electronics products use electrical machines to do all the testing. And certainly when we start reducing test, we can reduce electricity consumption, greenhouse gas emissions, and cost. And so the very first one, as we all know, test is non-value add, so we should continually try to reduce that and optimize that. So this is a wafer test, and we actually test the raw silicon before it goes into a product. And then we have what's called a silicon class test, and that's after the silicon is diced into an individual die and put into a plastic package that you likely have seen a black semiconductor. It's packaged. All right, so let's talk about revenue. Revenue for our test house is 1.2 billion. Tons of CO2 emissions per dollar. His emission factor is 41.3 times 10 to the minus fifth. Kilowatt hours per dollar. Okay, and then let's look at wafer sort revenue and silicon class revenue. And all these factors are going to help us calculate how much savings we're going to get by removing entirely or moving test cases and test time. So if we remove the first step, which is wafer sort, and we did successfully take this out because we had a lot of redundancy across our tests. And you see all the red X's are places that we actually took out test. I don't have the measurements for the ones in the back end here because none of those suppliers are hybrid and or none of those suppliers are sole source play on that particular test. So they have it all mixed in with all their other data. But for these tests, I have a test house who only does silicon tests, and I can measure the savings here. So we eliminated this step, and by eliminating sort, this is the savings that we get. And by optimizing class, which we took about 60% of our time out of class test, you can see the savings here. And then the total savings is 80%. Sorry, is 80% by just optimizing redundancies, removing test, and removing inspection. Now, I know that everyone may already have optimized their test and inspection, but the savings here were enormous percentage-wise. And you see how cost and greenhouse gas emissions and energy savings all go hand in hand. So from a test summary point of view, sort elimination gives us the convergence of reduced lead times because we don't have to do the processing. When we refuse costs, energy consumption, and CO2 equivalent. And the divergence is it increases yield loss slightly in materials waste at class test, and it impacted traceability at the die level. Because we used to do our traceability, we would start traceability at the wafer sort. So that means we had to do something different. And we came up with an alternate way to do traceability starting at sort. Now, class optimization, which is the second step where we actually just reduce time, it reduces cost, CO2 equivalent, and energy consumption. The divergence here is that we have higher yield loss of about 2 to 3%, loss of the packaging value add because we don't screen anything at the previous test station. But the trade-off was very positive for cost. Now, let's talk about, what customers expect and how that works with SKU design, and how can we optimize some of those customer SKU requests with delayed differentiation. And basically, the definition of delayed differentiation is the fact that we customize our product for a particular customer or SKU at the very last minute. And by creating SKUs correctly, or one physical SKU with many programmable options makes for a lot of ability to customize at the last step for our customer. And we can go back and reuse those SKUs and repurpose those SKUs for other customers. So if a customer cancels orders, we can take those units back and they're not scrapped. So this goes to the end of life aspect of where we can continue to reuse the same product. We have a lot of convergence here: reuse and reduce, low excess inventory scrap, and at end of life, we can repurpose it and sell it to lower cost geos who may still want this product. Divergence: one master SKU could have a little higher cost and use some more materials, but what we found is, in our case, that's not true. One last project, and I'm going to go quickly because I want to leave a little room for question and answer, is looking outside the factory, looking outside the supply base, looking outside customers, and looking at facilities and energy management. I worked with a commercial building, quite a large one, upgrading the controls for an aging HVAC system. And I think if you look across here, I'm not going to talk about all the numbers, but the savings was enormous. And the payback was 9 months. So if you go start looking at aging HVAC systems as a place where you can get some greenhouse gas savings and some energy savings, I think there are opportunities there. Beyond the factory, beyond the office. All right, so let's summarize. Many corporations are not meeting their ESG objectives and pushing out their net zero commitments. Some estimates put corporate emissions at 90% from their supply chain. Combining lean sustainability principles and metrics leads to synergies and outcomes for the triple bottom line of people, planet, and profits. Changing the units that you measure lean projects can accelerate adoption of sustainable practices. And then collaboration across the entire life cycle, up and down the value chain, creates opportunities to converge on sustainability. And that's where I'll end. And I really thank you for joining today. Hope you had got some good ideas. And if you have any questions, let's go ahead and tackle those.
Russell, great. Yeah, just a couple of questions and comments that I want to run through you here. Um, First question is about supplier collaboration for the project. Does this no longer result in seeking more responsive suppliers or decreasing defects accepted?
No, I don't think it changes the focus on defect reduction. Um, I think what I tried to talk about was because we work on that as well. What I talk about is where there's discrepancies in my spec versus the supplier spec, which causes him in his current process to have higher defects. And what's we found this not just on printed circuit boards, but we found it on our specifications. We make an analog product. A wireless card is an analog product. It's not just on off. And when you have analog products, you have a lot of specsmanship that goes to suppliers to make our product a little bit better and his product perhaps a lot worse. And we really had to work a lot with engineering to work on yields both on our factory and our supplier's factory because there's these constant trade-offs we have to make. And we do expect our suppliers to continue to improve their process, but it doesn't negate the fact that our specs and our desire for perfection in our little world can really impact our suppliers.
Great, thanks for that. Russ, another comment here. Um, Someone indicates that I think what you have here will also help with ESG reporting throughout the supply chain. What do you think about that?
I agree. I think it will. And I think that most people don't. Well, I know in any of our lean projects, we didn't calculate things this way to look across other opportunities, other areas of savings that we're getting, such as material savings and emission savings. But I do think it could definitely help.
Just to comment when you were going through your slides about the solder reductions and the change from leaded solder to lead-free solder. Just a curiosity, do you know who does use leaded solder? I thought that was gone. I shouldn't make assumptions, but are some countries, certain countries, still doing that?
There are a number of what I'll call lower tier economy countries that do
Mhm.
not specify lead-free solder. Most of Africa, India, all all have some products that are probably still on lead-free or leaded solders. And then, like I said, there's certain applications where certain defects could happen from
Yeah.
the lead-free
Just a
stuff. But yeah,
just an outsider observation. I thought that was gone, but
it is
maybe
not
gone
gone.
here. Yeah, it's not gone.
It's gone in the
Uh,
US, but it's not
ju
gone everywhere.
just in closing, someone else says, I appreciate the examples between lean and sustainability. Uh, we're down to our last 2 minutes. Any closing thoughts, Russ?
No, I just encourage people to start measuring their projects across more metrics than just cost and time.
Great. Good presentation, good attendance, good comments in the chat bar if you had a chance to see that. So thanks very much for your participation. Thanks for this wraps up this session and pretty much wraps up the conference. I think there's a closeout session, but this is the last of the technical breakout presentations. Thanks for wrapping things up with us, and we're 1 minute left in time, so we timed it right. Thank you, Russ.
Thank you all.